Hello everyone, I'm back with another lecture and today we are going to talk about something very important in biomechanics and also in physics as well. That is vector resolution and how we can solve vector problems. Okay, vector resolution in a very simple way. What is vector? Vector is simply, as we have discussed before, the magnitude and the direction, the size or the direction of the vector or something. Okay, you can take any of the object and just measure their size. Simple as that, their magnitude, and at the same time their direction. But sometimes a single vector can be difficult to understand or use directly. Okay, so we break it down into two perpendicular 90-degree parts. This is called, or this process is basically called as vector resolution. Simple is that perpendicular two parts. We can just take two parts of the vector and make it into a 90-degree revolution. Okay, we can just scroll it down. So if you want to know, like simple is that because two components make it easier to study motion in different directions. Okay, for example, if you can throw a ball in an air, okay, you have an example of this. Okay, simple. If you can throw a ball in an air, the horizontal component of the velocity tells how far the ball travels. Okay, how far a ball travels is the horizontal component of the velocity or of velocity of any of the object, and vertical components tells how high it goes. Okay, for example, you have throw this ball like this. Okay, now this distance that this covered is basically the horizontal component. Okay, this is horizontal component from here to here. It goes from here to here. Okay, this is the horizontal component. But this is the vertical component, that how high the ball is from the ground. Okay, simple is that from one side you have taken the ground, from the other you have taken the. So this is basically how the vector is basically represented. Okay, combine the lines, and this is basically how the vectors are represented. Even after breaking the vectors into majorly two parts, if you can add both the components, you get the same results. Okay, at the end you get the same vector back. Okay, so we are not changing the vector, we are only representing it in a very simple way. We cannot do that. Okay, this is very difficult component, you can just make it more difficult. Okay, already vector is a concept that is very difficult in physics, and we can make it more difficult by adding two more components, horizontal component, vertical component. No, this is for that we are going to represent in a simpler way. Okay, not in a more difficult way. Okay, before starting this, I can scroll it down and tell you how it looks like. Okay, this 3.15 figure shows that this is the perpendicular components of the what area of the vector. Okay, the vector composition and the two perpendicular components. It basically shows like this. Okay, so this is shows. Okay, you can just see here, this is the vector and these are the components or the new components that basically form. This is the vertical and this is the horizontal. Simple as that. Okay, now as you know that we can graphically describe through an arrow angle. The length shows the magnitude, and the basically arrow shows the basically the direction where the object is moving. Okay, simple as that. But the another method that is used, okay, the another method, the trigonometry solution of vector problems, it is basically the it gives you the exact answers of the vectors, but in a very easy way. Like you can just put formulas for sine, cos, tan on the calculator and any other objects, and any other the calculation, or you can just calculating CPUs, or you can just say that in laptops, etc., or any specific machines as a researcher, and you can just get the same result as you can just put your all the effort just to measure the vectors. Okay, so these are the simple concepts. We just use the angles and magnitude to calculate the components of the resultant force. Okay, so it gives trigonometry basically gives you the more accurate and quick solution, instead of using vectors and make a horizontal component and basically vertical component. So majorly this is the easy way to basically understand that, but this concept is not too much used in biomechanics. It basically used by the researchers more than a biomechanist itself, but it is very important to understand this concept. Of course, you might be become a future biomechanist, or you might be become a future researcher, so you need to understand these basic concepts very well. So these are the major concepts that we have to talk about all of these things. Okay, so here we have end the chapter. This is basic concept telling you how the vectors are represented in this example. You can just see here from this. Okay, here they have put in this the how they are putting the force, or how the force is acting on any object, where the object is moving, and they have taken the angle, and at the end they have find the result of that. These are the simple, basic mathematical, basic expressions. So you can just understand it by putting some formulas, cos and sine theta, etc., and just you can just get the answers. Okay. Here they have put the trigonometry because they have put the cos or log cos cosine. We are not discussing this in detail because this is the concept of mathematics and physics, but this is the basics you need to understand that okay, these are the major concepts. So this is all for today, and here we have done with our chapter number 3. Thanks for watching. If you have any query, you can ask. And this is all for today. In the next lecture, we're going to start the next chapter, chapter number 4. Thanks for watching. Bye bye.